we've talked already about linear equations that arise when you have constant increase or constant decrease situations where you're starting at a certain number and then going up or going down. This is another type of real-world situation that could lead to a linear equation. Okay, and the equations look like this. You may want to write this down on that very first title slide, just like I am. But the equations are going to be kind of in this form. AX plus BY equals C.
Math was cool until alphabet.
Right.
Where do we write this?
I would just write it on that title slide. Okay. It's really bugging me, yeah. AX plus.
How do we find A and B?
I'm going to tell you in just a minute. Okay. And really what it is here, A, B, and C are all going to be numbers. Okay? They're going to be whole numbers. This is what's called standard form. You're going to learn about standard form in the next lesson, but that's how these equations are all going to end up coming out. And basically, it's anytime you're combining two things and also using multiplication. You'll see what I mean in just a second. But just so you know, in case this question were to come up in the near future, like, I don't know, on a homework assignment or something, this part right here, AX plus BY, is what we would call a linear combination of A and B. So like, if you had a homework question that asked you for a linear combination of G and H, you would say GX plus HY. Okay? The letters they're giving you are just giving you different numbers or different constants to represent numbers. Okay? So the AX plus BY part is called a linear combination of A and B. Okay? Because that still makes a linear equation, right? It doesn't look like the y equals mx plus b that you're used to, but it still is two variables with no exponents in separate terms. Okay? An example of one of these. In pro hockey, a win is worth 2 points, a tie is worth 1 point, a loss is worth 0. Early in the season, the team has 11 points. Dee and Dominic, can you guys save your conversation for later? Awesome. Okay. Write an equation to express the relationship between the wins, ties, and losses. So if we're getting 2 points for every win, how would I write that in an equation?
2x plus b. I mean.
Going too fast. Just the number of wins. If wins is W, how would I show that wins are worth 2 points?
2W?
How about 2W?
2.
Yeah.
Not W equals 2. Because if I wanted to know how many points I had, I would take the number of wins and multiply by 2, right?
Mm-hmm.
Okay. Now, I have ties are worth 1 point. So plus 1t, because t is my number of ties, plus 0 points for losses, right?
Yeah.
And so for this team in particular, if I have 11 points right now, what would this equal?
3WTL.
Okay. Working too hard again.
3WTL.
Guys, whoa, stop.
3, 1.
Just a second. Let me speak. I have 11 points right now. If I take my wins and multiply by 2, my ties and multiply by 1, my losses multiply by 0, add them all together, what should it equal? 11. That's all I'm looking for right now.
What if it's multiplied by 0?
Okay, now wait a second. Here's the problem. Right now that equation is not linear, right? Because it has 3 variables. But what variable do I not really care about?
0.
The 0, right? 0 losses, that just cancels out. So really my equation should look like this. 2w plus 1t equals 11. Okay, that's my linear equation. That's a linear combination problem. That's a linear combination of w and t. Now we're going to make a table of all the different possibilities. And I'm going to blow this up so my writing doesn't look so bad. Okay. So let's start with 0 wins. If I didn't win at all and I had 11 points, what would that mean about my number of ties?
11 ties.
I would have 11 ties. Okay, James, can you put that away? Thank you.
So then the next one would be 1 and 10.
Okay, well, let's think about this. If I won once, that would be 2 points, right?
Oh, yeah.
So how
Yeah.
many ties would that be? 9 ties. Good.
Yeah.
What if I won twice? 7, because that would be 4 points from wins. If I won 3 times, 4
Does it just go
wins
down
would
by 2
be.
every time?
3,
It does go down by 2 every time.
5, 2, 1.
Okay, how do I know that I can stop here?
Cut.
Okay, yeah, if you were following your pattern on ties, you would have negative, and that doesn't make sense. Or if you had 6 wins, how many points would that be? 12, and I only have 11 points, right?
Yeah.
So it's impossible for me to have won more than 5 times. Okay, let's put these on a graph. Okay, and this graph is pretty self-explanatory here.
So we're coming up with how many possibilities there are?
Right.
The exclamation point?
Mhm. Nope. It's not using that same method. You're right that those exclamation point problems do ask you about the number of possibilities. These you're figuring out the numbers that would fit in an equation. I'm going to come back to that point in just a minute.
Is there a specific name for those equations?
Yes, it's the fundamental counting principle. Okay, so 0 and 11 would go there. 1 and 9, 2 and 7, 3 and 5, 4 and 3, 5 and 1.
Well, it just gives you the answer
Okay.
to this graph.
Yeah. Do you see that it's linear? Does it make
Uh-huh.
sense that it's linear? Okay. Do I connect these dots?
No.
Why not?
Because it's
Somebody raise a hand and tell me why not to connect these dots. Darian. There's nothing in between. Yeah, you can't have between 1 win and 2 wins. Okay, either you won or you didn't. So we're not connecting these dots. Which brings me back to sort of what Isaac was talking about a second ago. In this situation, it was very easy to make a list of all the different possibilities, right? Because it was all whole numbers and I had limits, like I couldn't go past 11 points because negatives didn't make sense. But there are some of these situations where you're going to be working with negatives or you're going to be working with decimals and fractions. And so then you can't come up with all of the possibilities, but you can come up with a few. And then if you came up with a few and then connected them with a line, you're essentially showing that those are all the solutions. Okay? So making a list like this is not always practical. It was in this case. Okay? Let's try another example. Take a second and just read this to yourself. Does it sound terrifying?
Yeah.
Okay, good. You're gonna see this exact same type of problem over and over again in this chapter, and I want you to get to the point where you're not afraid of it. So just real quick, okay. So we've got 20% of an X, 20% of X ounces, and 30% of Y ounces. So how do I write in an equation 20% of X?
0.2 times X.
There you go, 0.2 times X. Okay, there's 20% of X, and I'm adding that to 30% of Y, so 0.3 Y. So this is how much acid is in the first container, this is how much acid is in the second container. Okay, and then what's that going to equal?
9 ounces.
9 ounces total, good.
And that's it?
That's it for writing your equation. Not so scary, right? Okay. Now, read that next part and tell me the only number that's new.
2.7.
The 2.7 is the only number that's new. So all of that other stuff, we already have that. Oh, didn't mean to do that. And I can't undo it. Oh, well. We already have that handled in this equation. Where does that 2.7 go? Well, it doesn't replace the 20%, but what variable is with the 20%? X. It's 2.7 ounces of the 20%, which is
Whoa.
our X variable. Okay? So we are going to do 0.2 times 2.7 plus 0.3 times y, and that has to equal 9. Okay? And now I'm just going to solve. 0.2 times 2.7 is, I believe, 0.54. Someone check that for me.
Devin, you have a calculator right in front of you.
Right, thank you. Plus 0.3y. What am I going to do to solve from here?
Yeah, it's 0.54.
Okay, that's minus 0.54. So I get 0.3y equals 8,
0.46.
thank you, 8.46. Divide by 0.3,
I got 4.8.
And 28.2.
okay.
Wait, 8.46? I got 4.86.
9 minus 0.54?
Oh, 9 minus. Oh,
Yeah.
oops. I didn't multiply.
Okay. And that might be freaking you out because 28.2 is way more than 9 ounces. But remember, what we're really saying here is you kind of an illustration that shows what is happening in this problem so that you can wrap your head around it. Okay? You've got 2 containers of stuff. Okay? There's X ounces in this container, and there's Y ounces in this container. Now, in this first container, 20% is acid. Okay? So not the entire container is acid. It's probably acid mixed with water or some other solvent. In the second container, 30% is, whoops, well, you get the idea. So 20% is acid here. 30% is acid here. And if I add the 2 acids together, I have 9 ounces. But that does not mean I only have 9 ounces of stuff. I have a lot of ounces total. Okay? So you're gonna get stuck because you're gonna be getting answers like 30 or 40 ounces. And you're like, well, how does that work if I only have 9 ounces total? The 9 ounces only represents the amount of acid that's being mixed in total. Okay? Isaac, did you have something to say?
Yeah, it equals 50%, so in there be 18 ounces.
No, because this is 20% of however much is in this container. This is 30% of however much is in here, but they're not necessarily the same amount, so I can't just add the percentages together. Okay? If I knew I had 20 ounces total here and 20 ounces total here, then yes, I could. But I can't because it's 20% of a different amount. In this beaker, it told us that we had 2.7 ounces. We just found that in this beaker we would have to have 28.2 ounces. And if I did 20% of that and 30% of that, that would give me 9 ounces total.
Exactly.
Okay? Yes. So if I get a lot of people with those questions just wanting to take the 9 ounces and subtract the 2.7. It doesn't work that way. Okay, so that's what I'm trying to get you to wrap your head around, is that we're talking in percentages here. It's not as simple as you think it is.
When you add them together after you multiply them?
Mhm.
Oh, okay.
Yeah, so if you do 0.2 times 2.7, 0.3 times 28.2, you'll end up with 9 ounces. Okay? All right, that I think is review for you. The slope of a line. Does this look familiar to you?
Yeah.
Okay. Awesome. Yesterday we talked about rise and run. This is just the mathematical calculation of rise and run. Okay. So y2 minus y1, that's going to find the distance up and down. So that's really your rise. x2 minus x1, that's going to find your distance going left to right. So that's your run. Okay.
That's such a long problem.
All you do is 15 minus 3 divided by 4.
Yep, that's exactly right. If we call this coordinate number 1 and this coordinate number 2, and then remember every coordinate has an x and a y. So y2
It's 2.
would be the y coordinate from the second coordinate. So it would be 15 minus y1, which is 3. What's x2? 4 minus x1, which is negative 2. Be careful about your negatives. Remember that your formula has minuses in it, so if your numbers are negative, you're going to end up doing minus and negative, which is really addition. So 15 minus 3 is 12. 4 plus 2 is 6. Equals 2. Quick word on that. That one came out nice and happy, whole number. Okay, if they come out as fractions, leave them as fractions. Don't divide them and make them decimals. Okay, leave them as fractions. Are we good for today?
Somewhere.
Awesome.